Hello and welcome to the second video of dynamic robot trajectory generation based on information from 3D camera training package. In this video we'll be importing the necessary data to robot simulation software and also configuring the cell controller and beam picking application. And in the previous video we essentially created a camera system which is used to generate the workpiece coordinates for the robot trajectory planner. And in this video we will create the cell controller for AutoMaps. And here we have again the overview of the software and hardware infrastructure. We have the PC that's running the object detection framework and AutoMaps in the middle. And we have, in the previous video, we established the image data capture from the 3D camera and the image processing in the object detection framework, and we have also established the generation of X, Y, and Z coordinates, which will be fed to AutoMaps. And AutoMaps is the place where we'll be concentrating for this video. With AutoMaps we have two types of applications. We have the cell controller application and the beam picking application. The cell controller calculates dynamic trajectories for robot in general, and the beam picking application adds functions specific for dynamic beam picking trajectory calculation. We will need to install these both components separately with the respective installation files. The AutoMap cell controller can be an individual application which controls the robot cell operation on its own, or it can be integrated into other systems. The cell controller can act as a TCP IP client or a server depending on the needed configuration. In this module we'll be using the cell controller as the main cell controller in the direction of the robot controller. So we will install the cell controller using the installation file, and that packet will install the required components into the Windows program files. The pin picking system also requires installation of the cell controller system. And here we can see the configuration file for the cell controller, which is called cellcontrollerconfig.xml. It includes the necessary definitions for the robot controller to run. And here we have an example of the configuration for the image processing system, which we could use on a different PC as well, with the host IP and the host port specified, and also the output file work object coordinates as we saw in the previous video. The system supports picking of multiple types of workpieces, which in general is given in the parameter m part. And in the input file, the workpiece menu must contain workpieces with this name. And if there are several types of workpieces, the names are the workpiece with a supplementary number in the afterwards. And when the online planner gets a location of each part, which is specified in the text document that we saw in the previous video, the online planner essentially creates an own workflow for picking of each part. And here we have the example configuration for online planner, which is running on the same computer in this case as the image processing system. We have the template project file where we'll be updating the workpiece coordinates, and then we'll have the project file out specified also, in which we will write the new workflows as well. And then we have the configuration for the robot controller, in which we have the Omron Techman listen node, and also the robot's IP address and the robot port. The template.xml file defines the task that will be done in the workflow and can be configured by the operator. For example, the template part and template workpiece will be replaced by the correct name as well as the location of the work object. And here we have a full example of a template configuration. And if the gripper we have is controlled by simple IO commands, they can be also added to action commands. And in order to run the AutoMap cell controller in the robot side, we will need to establish a communication, which is in Omron Techman's case is used in the listen node, used as the listener node. And to start the data transfer, essentially, we will need to start the listen node from the TM robot, and then the vision software, the image processing system, and then finally the cell controller. And at this point, we have already set up a cell controller for AutoMaps, and in the next video, we will actually create the robot trajectories with the AutoMap simulation software. Thank you.